Hello everyone, welcome to our YouTube channel learnElectronics India. So we are continuing with the basic electronic series. So today we are going to learn on two circuit connections that are possible with any particular circuit. So those are series circuit and parallel circuit. So in our previous sessions we have discussed about open circuit, closed circuit, and short circuit. And the same way today we are going to see on these two types of circuit, that is series connection and parallel connection. So come on, let's get started. So first is series connection. So in series connection, we recall our water analogy, which is our very first class. So where in series connection, we connect the load one after the other in one entire loop. So if we see here on the left side, when we connect the pump and the water flowing through the line will be same, right? I mean, the flow of water will be same. So if you recall what we call the flow of water in our electrical analogy, it's current. So in series connection, the amount of current flowing will be same. Okay. So the same way, if the one bulb goes off, if you connect a circuit in series connection, if one bulb goes off, then the entire circuit stops working. It becomes an open circuit. So this is why we don't connect the decoration lights or our home our home wiring in a series connection. So the 3 points that we need to take in particular series connection, I consider are: first one, in series connection, the flow is same. So the current is constant. So in series connection, the current is constant. The next is in series connected bulbs, if one goes off, not only bulb, any load, if one goes off, then the entire circuit goes off. And the third one is very interesting and my favorite part, that is in series connection, no, the voltage, the total voltage adds up. I use it in my circuit building when I have a less voltage in those cases. So we know that the current that is flowing will be same. So what I do, for example, if you can see this picture here, I need a 12 volts output. What I do is I connect two 6-volt batteries in series. The same way, if you have two 9-volt batteries, so what I do, I connect two 9-volt batteries in series, then I have a resulting voltage of 18 volts, right? 9 plus 9 is 18. So this is how this uh, set works. However, the current is same. If you can see in this picture only, so the voltage that is flowing is 12 volts and the rating is 10 ampere hour. So the flow of current is same. So now we'll go for the next circuit connection, that is parallel circuit connection. So in parallel circuit connection, you see we have two different lines that are coming from pump. So this is number one and this is number two. So in parallel connection, the amount of voltage supplied will be same. However, so the entering current will be summation of first current and the second current. So in parallel connection, the voltage will be same. I mean, in the first line here, we have the total voltage supplied to the system is same as the other line that we have here. Cool. So now one more thing that we need to take in parallel connection is, when you connect a circuit in parallel connection, though the one excuse me, so one bulb goes off, the remaining circuit completely works. So this is why we make our decoration lights or the wiring that is done in our home is a parallel connection. So summarizing the points, we take these 3 points with respect to parallel connection. That is, in parallel connection, the amount of voltage is constant. Number 2, the parallel connection, the bulbs, if one bulb goes off, the remaining circuit completely works. Next, the third one. So if you connect two batteries in parallel, the resulting current will get added. However, the entering current is always equal to the leaving current. But when we are using in our projects, when we need more flow of current, then what we do, we connect both the batteries in parallel connection. So if you can see this image here, I have a two 6-volt batteries. What we have done, so in this image, what they have done was they connected two batteries in parallel connection, resulting to have 20 ampere hour, that is 10 ampere hour plus 10 ampere hour. However, the voltage is same. Cool. So now these are the two simulation models that I have done in using Tinkercad. So I want you all to try these two simulation models and experience the outputs that are formed. Since we all are familiar with the simulation platforms through our previous videos, so I want you to try these two circuits. One is series connection and another one is the parallel connection. So I want you to try these two using the simulation that in Tinkercad or whatever you are interested in. Cool. So the next one. So I want to say about the series and parallel combination connections in resistors. So I personally use it when I am short of resistors. So this I want to tell you because since we are hobbies, so when we can use this technique to get the resultant resistor. So what happens when we connect two resistors in series are the resulting resistor, the total resistance that we have in that particular line is combination of those two. That is, if you can see the series connection on the right, the total resistance on this line is summation of R1 and R2. The same way in parallel connection, the total resistance in this particular connection where we have 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So however, there are other than resistors, we have inductors and capacitors, but in regular operations, when we are working on our simple projects or when we are building our own circuit, we use resistors. So I am particularly concentrating on this point. So friends, what will be the equivalent resistance? See this. So if we have two resistors of 6 ohm connected in series, then you have a resultant of 12 volts. The same way, if you have three resistors of 6 ohm connected in series, we have 18 volts. The same way, if we have four resistors of 6 ohm connected in series, the resulting we have is 24 ohms. The same way, if you connect in parallel, what happens? No, the resistance get halved. So if you have same resistor of 4 ohm connected in series, in parallel, we have the total resistance of 2 ohm. If you connect two resistors of 6 ohm in parallel, then you have a resultant resistance of 3 ohm. The same way goes here, that is 12 ohm connected in parallel. You have a resultant resistors in 6 ohm. So please bear with me, though it's a bit theoretical, this is very much useful when we are doing our own circuits. So see, this is some cases that occurred when we are building our circuits. So what happens? So if I need a 5 kilo ohm resistor, so if we need a 5 kilo ohm resistor and we have only 420 kilo ohm resistors. So this happens in our case, like when we check our box, we are left with only 420 kilo ohm resistors, and there are but we need 5 kilo ohm resistor. So what are the possible combinations that we need to make to achieve our requirement? Come on, pause the video and can you just think of it? Cool. So what we need to do is we need to connect those 420 kilo ohm resistors that are available with me in parallel connection. Superb, superb. So the resultant will be what? Divided by 4. So we have our required 5 kilo ohm resistance, right? Superb, superb. So this is one interview question, which is very famous question. I hope most of you have already gone through it, but these I want to just make a revisit this question. Come on, so this question is something like this: why and when bird sits on a transmission line or a current lines does not get shock? So I want you to pause the video and take your pen and paper and just note the points. What are the points that you feel why the bird when sits on a wire, it does not get shock?
Yes, I feel these are the three reasons that is why the bird is not getting shock. The first reason is basically the bird is not completing the circuit. I mean, the bird is hanging on one wire and it's not touching the ground or it's not touching the other wire, right? So that is the reason it's not getting shock. So the second reason is if there is an insulation to the wire. I mean, if the wire that we are having where the bird is hanged is an insulated wire, then there is no effect on it. So that is another reason the bird not get shocked. And the third reason is so this is a bit curious to watch. See here. So there is a way for the bird to pass, right? See, if the current can pass through this way, right? So it can pass through this leg and followed by it can complete its path flowing that way. But we know that the current always follows the lowest resistance path. So that is also the one more reason. So if the resistance of the bird is higher than the resistance of the wire between these two legs, so then the bird will not get shocked and there is no current flowing through that. So these are the three potential reasons I feel. And so I have this question for you. I mean, this is like a task for you. So I want you to try this. So what does it mean now? So if you need, I need a 10 kilo ohm resistors, and these are the three different cases. So in the first case, I have only 5 2 kilo ohm resistors. So in the second case, I have only two 20 kilo ohm resistors. And the third case, I have four 1 kilo ohm resistor and two 12 kilo ohm resistors. So please tell me what are the possible combinations that I need to do in the each case so that I can have a 10 kilo ohm resistance as a whole. So in the each case. So that's it from my side. Hope you like this video. If you like this video, do like it. And if you have any doubt, please put it in the comment section and do share it with your friends so that they can enjoy this beautiful series. Thank you.